Assalamualaikum and good days to our lecturer, Dr. Mazlim Mustafa. We are from Group 2, AAB1072 Material Lab. So, we are going to present our final project. So, for this slide, is contain introduction to metallography, procedure for each processes in metallography process, and result and discussion. So for the first part of our presentation is introduction of metallography. What is metallography? Metallography is known as the study of the microstructure on all different kinds of metallic alloys. So for our final project, we use mild steel and aluminum steel. For the mild steel is a type of a carbon steel that contains a low level of carbon, which in range 0.05% and 0.25%. So for the first processes that's involved in the metallography is tensile testing. Tensile testing is a destructive test method that reveals details about the metallic material's tensile strength, yield strength, and ductility. So basically for the tensile testing is about the pulling force we apply to the material like this. So we will do the process until the sample undergoes breaking or fracture. So for the impact testing is test of ability of a material to withstand impact used by engineers to predict its behavior under actual conditions. So for the impact testing, we are going to use Sharpie impact testing that involving a pendulum. So for the next one, for the vehicle hardness test, I'm going to pass to Iqbal.
Thank you, Roy. For the next test, it is the vehicle hardness test. In this test, we will measure the hardness and the material's properties such as strength, ductility, and wear resistance. In this test, the material will be placed in a vehicle hardness machine where pressure will be applied to the sample. Once the machine is activated, the device will gradually exert a force on the sample and the value will be recorded in HV, which is also known as Vickers pyramid number. I will now pass the floor to Roy.
Thank you, Iqbal. Now I will present about mounting process. There are two types of mounting process, which is hot mount and cold mount. Hot mount used for hard and brittle materials such as ceramic, composites, or some metal. Furthermore, cold mount used for soft and more ductile material, which require material mixed with a hardener. In this laboratory process, we apply cold mount for our sample, which is aluminum and mild steel. Next, I will pass to Faiz for polishing and grinding process.
Alright, for the grinding process, there are three types of grinding process. The first one is coarse grinding. The purpose of the coarse grinding stage is to generate the initial flat surface necessary for the subsequent grinding and polishing steps. After we have done the coarse grinding, we must do the medium grinding and the fine grinding. The medium grinding process is designed to produce a scratch-free surface by employing a series of successive finer abrasives, and for the fine grinding it is done to improve the performance or characteristics of the material. Next is for the polishing process. The polishing process involves the use of abrasives suspended in a water solution on a cloth-covered electrically powered wheel. Following the final 600 grit fine garnissage, the sample must be washed and carefully dried before proceeding to the first polishing stage.
So for the procedure for each processes, I'm going to explain to you testing, tensile testing and impact testing procedure. For the first one is tensile testing. We prepare our specimen and then we adjust the test machine and we install the specimen in the machine. So for the next one, we will start the tensile testing test procedure, which is start the test machine, slowly and evenly load, carefully observe the force pointer rotation and drawing device drawing distribution. After the sample is fractured, we will remove the test pieces and we are going to measure the distance by using vernier clipper for each part, which for the shorter one and the longer one. After we measure the distance by using vernier caliper, and we will still use vernier caliper to measure the diameter of the key. So for the impact testing, we are going to prepare the specimen. For the dimension for each specimen, which is aluminium and mild steel, is 50 millimeter times 10 and times 10. So for the depth are located in the middle of the sample. So the depth is going to be 2 millimeter. And before we start the impact testing, we must do two things. We must ensure the position of the pendulum at its starting position, and calibration of impact tester. For the calibration of impact tester, what we are going to do for the calibration of impact tester is we are going to turn the dial gauge to the end value. The end value is going to be the maximum value in the calibration of impact tester. So next we are going to release the pendulum without placing the specimen. After we do the calibration of impact tester, we are going to put the specimen and we are going to release the pendulum. After the pendulum is released, the specimen will be cut off due to the swinging of the pendulum. From the cutting of for the cutter specimen, we are able to calculate the energy absorbed by using dial gauge. Next, I'm going to pass to Iqbal.
Thank you, Taju. For the Vickers harness procedure, it is done within 8 steps. First, place the sample on the stage. Second, you on the screen click and drag the mouse to move the sample into position. Number 3, scroll it into focus. Step 4, properly adjust the settings of the machine for proper testing. Number 5, use the overview camera in the machine to adjust the position of the indenter. Number 6, properly adjust the indenter such that it is properly positioned above the sample. 7th, start the test. And finally, the final step, take notes of on the following experiment, after which you should remove the sample and then use another sample for comparison. Thank you. I will now pass the floor to Roy.
Thank you again, Iqbal. For mounting procedure, first we select a mounting material depending on the material type. Next, we mix the mounting material with some epoxy resin to make the cold mount. We also add silicone mount release to make the epoxy resin stronger. The time taken for this process takes around 20 minutes. After the mounting process finish, remove any excess material around the specimen. Next, Faiz will explain more about grinding and polishing process.
Alright, so from the illustration above, we can see that this is a grinding process done by a student during our lab session. Okay, so now I will explain the steps for coarse grinding. The first one is we need to mark the specimen. Firstly, we must draw a straight line on the specimen. After that, we must turn on the motor and the flow of water is adjusted. Next, we use a 120 grit belt. We must press the sample against the 120 grit belt with uniform pressure so it will deteriorate uniformly. And next, after a amount of time, we must look at the sample and lift it to check whether all the lines are parallel. After that, we must wash the sample so all of the debris is clean using tap water and the sample is dried using paper towel. And lastly, for the coarse grinding step is we must use a 180 grit belt, which is more fine than 120 grit belt. This process is used until it is completed. And now for the medium and fine grinding steps. The first one is usual. We need to draw a line on the specimen. And after this, we must use a 240 grit, which is the lowest in the coarse category. After that, after each grinding step, we must rotate the sample at a 90 degree to each stain. After the scratch is gone, we must use a sufficient amount of water to provide lubrication for the sample and also to flush all the unwanted products. And lastly, we must rinse the specimen carefully after each grinding step and also make it ready for polishing process. And now for the polishing steps, the first one is we must use safety goggles before the polishing is conducted. After that, the sample is polished using a 25 micron nylon polishing cloth. Also, a small amount of aluminium oxide is applied to the polishing cloth. For the polishing, both hands must be used for polishing. And the microns are between 5 to 25 microns and the process takes between 1 to 2 minutes. After that, the specimen is both washed and dried. And finally, for the final polishing stage of 1 micron, it should take between 30 seconds to 1 minute. Next, I will call upon Roy to explain the etching process.
Alright. For etching process, etching is a process used in manufacturing and production to selectively remove material from a surface in order to create a desired pattern or shape. In this process, we use chemical etchants. Etching procedure. First, identify material to be sampled based in the analysis objective. Next, we got aluminum sample and mild steel sample. For aluminum sample, we perform color etchants. It takes 10 to 30 second immersion. For mild steel sample, we use nitrile etchant. It requires at least 1 minute immersion. After that, we mount the sample after etchant process on the machine based on sample immersion time. Lastly, next, put sample on dry box to dry it. For safety precaution, always use rubber gloves to protect our skin from the chemical agents. That's all.
Okay, so for the result for science testing, as you can see, we have two plotted graph for the aluminium and by steel. For the aluminium, for the stress is going to be 290 megapascal, and for the by steel is going to be 970 megapascal. So as you can see, there is a differences between aluminium and mild steel in terms of stresses. So we can conclude from that mild steel has bigger stresses, or the mild steel have higher tensile strength than aluminium. This is because mild steel has larger density than aluminium. So for that inference, we can use also the impact testing. For the impact testing, this scale show that the average kinetic energy for the mild steel is 73.101, and for the average kinetic energy for aluminum is going to be 30.265. Therefore, we can conclude that aluminium that mild steel have higher tensile and impact strength compared to the aluminium due to its density. So this is sample during grinding. So for the left side is the beginning of the grinding. The second part is the middle of is the result in the process. And for the last one is the final product for the grinding process. So for the last slide, this is result from the Vickers hardness testing. So for the left side is going to be the picture of the Vickers steel microstructure, and for the right side is aluminium microstructure. So we can conclude that aluminium have 175.5 HP, while mild steel have 359.8 HP. From that value, we can conclude that mild steel is harder than aluminum. That's all from me. That's all from us. Thank you.